All right, guys, so we've made it to the last section of alcohols, which is on synthesis. So work through this reaction map in your book, and it's got all the reactions we've learned so far, plus your alcohol reactions down here. It's a good idea to review. How do these work over here? How do we do, is this oxidation or reduction? Is this oxidation or reduction? How does that work? You don't have to know the mechanisms for the oxidation reduction so much. Because they're somewhat complicated, but do know how the reductions work generally and how all these substitutions and eliminations work. These are also new here. Okay, so with the alcohols, you need to know how they react, but you also need to know how to prepare them. So here are all the new reactions that you've learned this quarter, which are highlighted. And I would say do know the mechanism for these ones since we've gone over them, and for these. And for this, you should know a little bit about those mechanisms and how they work. Now let's try some multi-step synthesis just to practice. We have H3O plus in the first step. How does that react with an alkene? So you have to think back to your alkene reactions. I think you remember it adds the OH group, and so we have an alcohol. So after step 1, you're going to have an alcohol here. And then step 2 is going to be oxidation, because I see this chromium here, chromic acid. Now for the other one down here, let's follow this one through. Br2 is going to give me trans dihalide, and then excess sodium amide, and then I have water just to neutralize that. And then I have Markovnikov addition of water, which then tautomerizes the enol to the ketone. I'll write the enol here just so you see. This will put an OH group here, or on the other carbon, it's symmetrical. And then this enol tautomerizes to this ketone. All right, so that's an example of how we've incorporated a lot of reactions. You sort of are already familiar with that from the last chapters and here. So coupling, OH addition and then oxidation. So let's work through some of these together. So here I see, I want to highlight, what are the changes here? So that's a 2-carbon unit. Here's a 2-carbon unit. This 2-carbon unit probably came from this 2-carbon unit. All right, so what I want to do is add an OH anti-Markovnikov, but I can't add it to this because it'll be an aldehyde because this is oxidized. So I need to reduce this first. So I'm thinking maybe make that a double bond first. So like this, and then so that'll be my intermediate. So I'll make that, and then I'll make that. Okay, so to do that, do you guys know what I need to do first right here? I need to reduce that. What do I need? Either H2 Lindlar or sodium metal in ammonia. And then once I get that alkene, it doesn't matter if it's cis or trans, there's no cis or trans here. Then I want anti-Markovnikov addition of water on an alkene, so BH3THF, hydroboration followed by oxidation to replace the BH2 group. Okay? All right, good. And so why is this in this chapter? Because we're making alcohols. This is a alcohol synthesis chapter. Okay, it's also alcohol reaction chapter. How do I take an alcohol and react it to something else? And I'm going backwards. Let me see if you guys can figure this out. And also this one here, changing 1, 2, 3, 4, 1, 2, 3, 4. Use that strategy of counting carbons. See if you're doing any alkylation. We're not. So just figure out how this got into an aldehyde from an alkene. It's going to be multiple steps in order to do that. And then this one's interesting too. This one is to get to an alkane, which is a dead end. Okay, so there's a way to get rid of this and then turn it into an alkane. So all of these involve multiple steps. Let's pause it and see if you guys can come up with these answers here. Okay, so for this part B, I'm thinking the OH group needs to get eliminated, so we get an alkene, then we can brominate either geminal bromination or 1,2-dibromo using Br2, or excess HBr is what I end up using, and then eliminate with sodium amide. Okay, but this is primary, so I can't use acid here. I have to use one of those reactions we learned. So maybe I'll use tosyl chloride to make this a good leaving group, and then I'll eliminate using NaOH and heat. And then once I do that, I can use HBr excess, or I can use Br2, and then I can use NaNH2 excess, followed by water to neutralize that, and make sure that this is protonated and neutral. Okay, for part C, I'm thinking I need to change this into an anti-Markovnikov addition of water and then oxidize it to an aldehyde rather than a carboxylic acid. So to do that, I'm going to use hydroboration oxidation to get my alcohol, primary alcohol. And then my third step is going to be PCC rather than Jones or chromium-based reagents that are strongly oxidizing. PCC is my mild oxidizing agent, although it's also chromium-based. My last example is this secondary alcohol. I need to get rid of that alcohol group, but I can only do it by turning it into an alkene, and then I can reduce it further. Can you think of what reagents I need for that? The first one is, since this is secondary and not tertiary, I want to again use either tosylate, or I can use Sokol or PBr3. And then once it's a halogen here, then I can just eliminate it using NaOH. You could also use tert butoxide. It doesn't matter where the double bond is, because you're just going to use H2 platinum or PD palladium at the end. Alright guys, for these reactions, notice that you're doing something different now. We are adding some carbons here. So that means we need to do an alkylation reaction. But rather than turn this into a triple bond, the alkylation reaction you learned is, you remember? It's the Grignard reaction. But don't put R. Tell me what R is. Okay, so go ahead and see what happens, and then don't forget at the end, Grignard leaves you with an alcohol if you use a ketone or aldehyde. So how do you get the ketone back at the end? That's a little twist on the Grignard. Alright guys, so for this one you need ethyl magnesium bromide. That's going to attack your carbonyl. Then you're going to end up with an oxygen ion, and then water will protonate that. But you'll get an alcohol here, so you have to oxidize it using Jones reagent. Or you can put sodium dichromate or chromic acid or chromium trioxide, any of those stronger ones. PCC will also be fine because we are just making a ketone here. So PCC is also okay. Similarly, you guys can probably figure out how to do this one. It's almost the exact same thing, but with methyl magnesium bromide instead of ethyl. Alright guys, let's walk through this one together. Here I'm seeing these carbons like that. 1, 2, 3, 4. So obviously I need to add a methyl group here, so I'm going to use that Grignard idea from the last problem. But I need to have an OH here first. So I need to add an OH from this pi bond, and I need to add it anti-Markovnikov. So that's gotta use these guys here for that. So once I do that, then I'm going to end up with this. And then I need to oxidize it in order to add a methyl group. This is not just going to attack here. I need it to be a carbonyl group. So I need to oxidize that, meaning I need to go to this compound. And now I could have a methyl group attack. But then after the methyl group attacks, this is going to be an OH group, and then I can oxidize it to there. So why don't you guys tell me then, get my anti-Markovnikov OH, and then what do I need to get it to here, and then what do I need to get it to here, and then what do I need to get it to there? Alright guys, so in order to go from here to here, I need to oxidize. So I'm going to use Jones reagent, or actually I don't want a carboxylic acid, so I have to use PCC because of this H here. This is a very sensitive bond for oxidation. It could get an OH there if it's too strong, so I don't want to use anything other than PCC there. Or you could do Swern oxidation also. Once you do that, then you got this. Let's see, then we want to use our methyl magnesium bromide to alkylate. Whoops, wrong guy. Okay, alkylate that. Okay, so methyl magnesium bromide followed by water workup to neutralize that, and then I need to oxidize it again. So oxidizing it in this last step here. is going to be, again, PCC or Jones is fine there. All right, so for this last one, wow, looks really complicated. You're starting with 2 carbons and you're trying to get all of these carbons on there. So let's figure out how to do that. Definitely going to need some alkylation reactions. Go ahead and give that one a try. There's multiple answers that are possible. All right, guys, I just thought I would share this with you. I was just doing this problem, and I thought, well, we need to alkylate, and it's already a triple bond, so that's ideal for NaNH2 coming, deprotonating, getting your alkyl halide to get this long chain, then doing it again to get more carbons on there. But the problem is, you guys see what's going on here? If I added a carbon here, so here's my 2 carbon unit originally that I'm thinking, and so I just needed to add 1 more carbon here. But if I do that, what's the problem with this last step? The problem is that I don't have a Markovnikov, anti-Markovnikov regioselectivity because these are both substituted the same way. So I can't control where the OH can be added if I used HgSO4 or BH3. It's going to add to both of them, so I'm going to get a mixture. So I need to maybe keep my terminal alkyne, have some selectivity, and then see if there's a way to add this group together later. So maybe a better option would be to use the Grignard at some point. And so instead of cleaving it here, maybe I should think about Grignard, and this can attack here, and then I can use that idea. So maybe I need to make a longer chain first. So I'm going to use this as my basis for 2 carbons. That means I only need to add 1, 2, 3 more carbons. So I'm going to go to 3 carbons. And then once I have this, I can make my anti-Markovnikov aldehyde from that 1, 2, 3, 4, 5. And then I can add my 2 carbon group as a ethyl magnesium bromide and do a Grignard reaction, which is going to give me this. And then I can oxidize that OH group. So there's probably an easy answer right there. So the reagents are going to be, you need NaNH2, and then you need your propyl halide, so I'll just call it bromide. Then you need the anti-Markovnikov, R2BH, or BH3 if you want, THF for hydroxide and peroxide. That's hydroboration to get to here. And then we're going to do our ethyl magnesium bromide to do our Grignard and add this ethyl group right here. And then after that, we're going to need water workup to neutralize it and get this H on there, so water or dilute acid. And then the last thing is I got to oxidize this to there. So this is going to be Jones reagent. You can just write Jones or PCC or write out some of those chromium reagents if you want. Okay, so obviously you either followed that or you had some trouble seeing. Again, my strategies are always highlight these, try to figure out what part of the chain needs to be added where. Is there alkylation going on? Do you have more or less carbons? Do you have, if you have more, you have alkylation. So we've only learned 2 ways. Triple bond, deprotonated, hitting an alkyl halide, or Grignard reaction. So really the only 2 options you have if you're growing your carbon chain. And well, it's also cyanide, but we can do SN2 with cyanide. That's another one, but I don't think you're going to see that very often right now. But just another option is you can attack that SN2. So anyway, small handful of alkylating agents, and then you also need to use those reactions where you make pi bonds or use pi bonds, just like we saw at the end of the last chapter. And then you also need to have facility with those oxidizing agents, oxidizing and reducing. Okay, so you've seen a lot of oxidation on these, maybe just practicing some problems with reducing agents as well. And the key is really understanding these reactions here. So knowing how to go one way to the other and really focusing on your functional group transformations. Okay, so if you know you have an alkene, what are all the different groups that you can go to from an alkene? Wow, it's a lot, right? And then those groups, once you are comfortable with those one step, then you can venture farther and say, okay, once I make this, now what are the possible ones from here? Oh, I can make that, or here, or I can make that again. So, you should be able to start connecting those up. The best way, I think, to do that is just to write out the reactions till you start really learning them forward and backwards. You just got to know them in your sleep. So looking at them every day, writing out the mechanisms really helps you to solidify, okay, the way of thinking that helps. If, this OH group attacks here, then what happens to it? You'll start developing a sense of intuition about it that's really going to help you a lot. All right, good luck, everybody.